1 by square root of 2 pi of theta into exponent of minus of x minus theta whole square by 2 theta square. So that means if we write the joint PDF, so joint PDF would be x1, x2 and so on, x and theta. So that is product of I is equals to 1 to n, 2 pi of theta into exponent of xi minus theta whole square by 2 theta square. So that is nothing but 2 pi whole to the power minus n by 2, theta whole to the power of minus n, exponent of minus summation I is equals to 1 to n xi minus theta whole square by 2 theta square. So that means if we consider the exponent, so this likelihood of theta is nothing but 2x whole to the power of minus n by 2, 2 pi whole to the power minus n by 2. So theta whole to the power of minus n, exponent of minus summation xi square by 2 theta square plus summation xi by theta minus n by 2. So that means if we ignore the factors not dependent on the data, so the dependence on the sample x and theta occurs only through this theta to the power of minus n into exponent of summation xi by theta minus summation xi by 2 theta square. So that means t1, which is summation xi, and t2, which is summation xi square, are sufficient statistic. So now if we consider expectation of t1, so expectation of t1 is n theta, and expectation of xi square is nothing but variance of xi plus expectation of xi whole square. So in this case it is theta square plus theta square, which is 2 theta square. So expectation of theta 2 will be n times of 2 theta square, which is 2n theta square. And so that means, and if we find expectation of t1 square, that is nothing but variance of t1 plus expectation of t1 whole square, that is nothing but n theta square plus n theta whole square, which is nothing but n into n plus 1 theta whole square. So now, like, if I define the function z of t1 comma t2 as t1 square minus n plus 1 by 2 t2. Now if I find expectation of t1 comma t2, so we can clearly see expectation of t1 square is n into n plus 1 theta square minus n plus 1 by 2 into expectation of t2 will be 2n theta square. So that means it is 0. So that means we found a non-zero z with expectation of z of t is equals to 0 for all theta. So therefore t is not complete, but t is sufficient. So by using counterexample, we are proving that t is not complete, whereas t is sufficient. So therefore option A will be the correct answer.